Unmute. And I'd like to introduce David. Hang on, microphone also. I'd like to introduce David H. Johnson. You have to have the middle initial because if your name's David Johnson, there's a bunch of other ones that have the same name as you. He's the executive director of the Global Owl Project and studies burrowing owls out in Oregon for almost a dozen years now. Lives in Virginia, so he's coming to us live from Virginia. So David, I will turn it over to you. Go for it.
Good afternoon, folks. Depending on where you are, I appreciate that you are taking the time out of your busy lives to participate in this exercise, and wherever you might be, and it might be a lot of places the way it sounds. So I've been working with owls for 46 years, and I have had a passion with them. When an owl came to my canvas pup tent when I was 11 years old, and it called to me, and sitting just inches from my face, I was inside the tent, it was outside, and it called for 20 minutes. It was an eastern gull at the time. I didn't know what species it was, but it certainly made an impression. And so now I've been dedicating my life since 2005 exclusively to owls, and I had a passion for them much before that. But I didn't pick owls, they picked me. And so this is a natural extension of everything I do. And so I've had the honor to work with owls now quite intensively for many years. And so the focus of today is to share some knowledge about burrowing owls. I've worked with them for the last 12 years on some projects around the Western US, but also in other parts of the Americas. So I think I'll step into the PowerPoint if I can here. There we go. Does everybody see that okay? And can you hear me okay?
We can hear you, but we don't see your video yet.
Okay. So.
Got to do the share screen again.
Okay. Back. Get out of this. Go down here. Go back here.
Get out your magic wand.
Yeah. So why is this? There we go. Share screen. Okay, recent discoveries for 500.
Ta-da! Perfect.
Hey.
Good to go.
Very good. Thank you. So I'm wanting to talk about recent discoveries about burrowing owls in this presentation. So I'm going to jump around to a number of different things, much of which I've learned, but I've also learned from many others, of course, around the world on the species. Burrowing owls are, they're small owls, and they nest in burrows, as the name implies. They're 110 to 230 grams. Their diet is small mammals, a lot of insects, reptiles, amphibians, small birds. The typical lifespan is 4 to 5 years. The oldest I know of is just a little over 10 years, a bird from Southern California. They breed at age 1 when they are essentially 10 or 11 months old, and thereafter. They can have 0 to, the greatest number I know is 12 young one pair had. Despite what people think that they are diurnal, they're not diurnal. They're nocturnal and crepuscular in that order. They're rockets at night. And we see them during the day because they're in very open landscapes and there isn't a lot of place for them to be. They are nest guards and often sitting outside during the day. Important is that the burrows are fundamental to their ecology. I can't emphasize this enough, that without burrows, they would not survive. And so we'll spend some time on that. They have a very wide distribution in the Americas. Not quite as wide as this map portrays. They're certainly not in the forests of the Amazon, but in the grassland areas and shrub steppe areas of North, Central, and South America. The image I want you to remember is like this: very open landscapes, big open grassland plains. They are not in the foothills and in these side hills, and rarely are they up to the base of it. They're more down here at the bottom, and the lower foothills where it's nice and open and they're more safe in that environment. So I want you to get a good image of this broad open landscapes. That was in Washington State in the US. This is in Oregon, Southern Oregon. This is shrub steppe. This is Great Basin big sage. Okay, but here again, the whole point of this image is to show you that it's wide open landscapes. They have a commanding view. Youngsters here by this nest burrow that was made by a badger. Majority of the burrowing owls use holes made by other fossorial animals. The prairie dog, the ground squirrels here, desert tortoise or gopher tortoise in Florida, the American badgers, okay, or other ground burrowing animals. They can make their own burrows if the soil conditions are just right where the owls are resident species. In Oregon and Washington and much of the western US, the owls are migratory. They don't have enough time in the nesting season to be able to find the right soils, dig the right holes, find the right territory for reproduction, and be able to survive all that while they're digging. And so they use burrows of other mammals, other animals. This is a picture from Aruba. If you can see my cursor, there's the male here and female here, and the burrow in between. They've dug it themselves. But here again, this is a relatively open landscape. A little bit less so in Aruba, but you get the idea that this is an open grassland and they prefer the more open places in it. These are the topics I want to discuss in this presentation. Capture and migration, mate selection, nest decoration, conservation aspects, artificial burrows, photography, and then kind of what's coming up next in the queue. All right, so I'm going to spend some time on each of these topics. I lumped capture and migration together because for me, I learned about capture as I learned about migration. It's fundamental, the linkages. The study area that I've been working on is in North Central Oregon at the Umatilla Army Depot. This gives you a general sense as to where it is in the United States. Okay. Here's a little closer up. This is 1 square mile, these 4 agricultural circles. So 1.5 kilometers. Yeah. 1.6 kilometers. So it gives you a sense of spatial scale. The depot is this area in brown. Okay, and it's 17,000 acres, 6,800 hectares. And for the most part, it looks like this. It is a wide open, treeless landscape, except where the military has put in 1,000 of these bunkers, these concrete igloos. And these igloos during World War II and after held munitions for the war. And then later they held about 13% of the US chemical weapons, all of which have been since incinerated and destroyed. And so what's left now is the empty, cleaned out igloos and this wonderful wide open landscape that I have a lot of artificial burrows in for the owls. That's my pickup way down there to give you a sense of spatial scale. When I first started trapping, the main techniques for capture involve this walk-in trap. And it's a wire mesh trap with burlap. And people were telling me, well, David, you should be able to catch 70% of the females and 30% of the males in it. And I thought, respectfully, okay, that's good. But I don't want to catch some owls. I want to catch every owl. I want to catch every owl in the study area every year. And every place I go in my Global Owl Project work, I want to train people how to catch every owl. Okay. I modified the trap a little bit, made it black, lighter mesh door so it screens in, weed fabric on the outside. Okay. The methods are the same. You put the trap in kind of as in a tunnel extension, if you will, all right? And then bury it with dirt. So it actually, to the owls, sort of looks like a tunnel extension, okay? I put some decoration out front to make it look like there's somebody going in and out and all of that. So the other thing I use, or used to use, is this bow net. It's a 3-foot or 1 meter diameter bow net. It's set. Here's the trigger mechanism. It has a live mouse in a little bait cage. The stake holds it down so the owl can't pull the bait cage toward the trigger, but only away from it. And when it's triggered, it goes like this. And of course, it catches the owl inside. Here's what it looks like when it's in the field in a set position. A little bit of camouflage. The owls know it's there, but they're interested in the mouse, okay? And I would catch the majority of females, or could if I wanted to. I can catch most of them in the walk-in trap, but I would catch about 95% of the males if I wanted to in the bow net. I wouldn't catch them all. The really old timers, the really good hunters, would fly over my trap. And they said, thanks, David, but I can do better myself. I can catch kangaroo rats. I don't want to fuss with your little mouse. I know it's a game and I'm not playing. And so, very fine. Okay. This guy, this male, is what turned the page for me. If you see this little epoxy stem sticking out, that is a geolocator that I put on this male. And that's this portion of the geolocator. Here is the light sensor. A geolocator is a tracking device. It only records the amount of available light every 5 minutes, and it records it, but you have to capture the bird next year when it comes back to know its migration. There's these little prongs right down here. You download the data. Underneath is a battery, but the only part that sticks out is the stem so that it's above the feathers. So whenever the owl is in sunlight, it records the ambient amount of sunlight. So in the morning, if the bird is outside, when the sun comes over the horizon, there's a big spike in the amount of available light. It's bright during the day, and then it goes down at night at sunset, just as the sun dips below the horizon. Like the ancient mariners, if you know your time since Greenwich Mean Time, you can back calculate latitude, longitude based on sunrise and sunset times. So I used that back calculating the migration of the owls. Here's what it looks like with a Teflon harness. Okay. It's put on as a backpack, all right, a little crimp tube on the front, and it's snug but not tight on the owls. And lo and behold, the red here are females and the blue are males, okay? All of the females went south for the winter. And the reason they do that is because they want a safe place to winter where they can put on weight and get in great shape so that when they come back next spring to the nesting grounds, they're in great shape to lay on average 8.8 eggs on the depot, as well as incubate them for 23, 25 days, and then brood the youngsters. Well, meanwhile, they're dependent on the male for all the food that he can deliver. Well, what the heck? The majority of the males went north for the winter. I thought something was really wrong with the data. And some of the males, these are actually young males, went south. And over in Idaho, it's so cold, they don't have any choice. They have to go south. But males from Oregon and Washington went north for the winter. This is what it looks like in winter, in where the areas where they were. In fact, here's an owl right here in the middle of the screen. So this is snow, not deep snow. They can access burrows that they find, and they're really good hunters. These are tough guys. And their strategy is, if I can survive the north, guess what? I get to be first back. If I'm first back, I get dibs on the best territory and the best burrow. And if I can do that year after year, I memorize that landscape and I become the top guy on the totem pole. These are tough guys. The oldest one I've had is 8 years old. And it's like no fooling. They're not putting up with anybody else. They want that territory. They're ready to sacrifice their life in the cold winter so they can have it. When that dawned on me, when I first realized that, I realized how incredibly important the burrows are to the owls, especially the males. Now remember, we had trouble catching males. They didn't want to go into the walk-in traps. Some of them were shy about the bow nets. But so now I have a little folding speaker and an MP3 player. I put it in the entrance to the tunnel. I put a trap on. Okay. Now I'm going to stop screen sharing with this, and I'm going to go to a video. So hang in there with me.
We don't have the video. We're just hearing the audio. So you have to re-screen share.
Okay.
There we go.
Okay.
There.
Okay. We'll start it over so everybody can see it. So this is a trap that I have put an MP3 player and a speaker into. This is the resident male. I think you can figure out what's going to happen next. The sand is hot that day. That's it. So are we back on?
Yep.
Okay. So what you watched there was a 2-year-old male, okay, and not a very dominant guy who had none of the males really want to fight because the risk of injury is so high that if you lost an eye on just a quick scrape with another competitor, another guy, it'd be game over, okay? So you can't really fight, but you can do everything else. And you certainly want to fluff up, you want to demonstrate your prowess, you want to vocalize. And so this guy was vocalizing and then jumping around and dancing around. He knew the other guy was in there. And I purposely used the call of an underweight 2-year-old single male, okay, as on the MP3 player, because I want to play a punk. I want somebody that everybody's going to want to beat up on for even thinking they can take my burrow. I'm not having it. And it turns out now with that, I don't catch some of the owls, I catch them all, okay? And so I can catch all of the males. And it turns out that the older the males get, the faster I catch them, because they're not tolerating any young punk in their burrow, a pesky intruder, which is what I want to be with that MP3, just a pesky intruder. I don't want to be a dominant competitor. I just want to be an intruder, somebody that they're going to shake out of there. Just come out, come out, come out, or don't make me come in there. If I have to come in there, I'm going to whip you, okay? Well, they all go in there because he doesn't come out. I catch him, boom. And my record right now is 45 seconds in terms of how fast some of these males get caught. Now that guy took a time, he took half an hour almost, which is standard fare, huh? Okay, so, but that's one of the techniques that we have learned about, or I've learned about, and we've learned about capturing these owls. Okay, very good, let's go on. During that time, in now 2010, 11-ish, okay, one of the very first transmitters, satellite-powered, solar-powered satellite transmitters, recorded these 4 observations. It started in Saskatchewan, and the owl moved down to to Baja, okay? And so this is what the transmitters looked like at that time. They were big, they were long, the antenna strung down, it was 12 inches long. They had a neoprene patch underneath the transmitter. They trimmed the feathers. I was going like, yeah, I don't like this. And they didn't really work, because as soon as the owls would molt in September or October, the new feathers that came in, right when you needed the transmitters to work, the new molted in feathers would cover the solar panel. You just spent $3,500 for something you're not getting any data from. Oh, okay. So this is what the model looked like at that point in time. So I redesigned it. I put a lift kit underneath. This is all epoxy now. Angled the antenna at a 45-degree angle. Trimmed it so it was only 6 inches long, not 12 inches long. But in order for that to work well, we had to modify it so that there was connections to copper connections right down to the transmitter base, so that the owl itself would be the ground, the electrical ground, so that when the signal was sent to the satellites, 1 pulse per minute, it would go out the end we wanted it to go out. Oh my. So I thought, okay, now how are we going to attach it to make it as light as possible? People had been using 40-pound test, 16-kilogram test, nylon-coated stainless steel cable on peregrine falcons. I said, well, I know the owls are tougher, so let's double it. Let's put on 80-pound test, nylon-coated. Okay, well, half of the owls chewed through it. It's like, whoa, they are tough. And they just chewed through the stainless steel cable. And I was going like, wow, that's an expensive lesson. So, all right, fine. And then I found out that here you see the female here, see the antenna sticking down, okay? The male is helping her bite the cable. And here she is dropping it off her leg. He helps her get it off. It's a tag team thing. It's like, give me a break here. So, all right. So then we went back to using Teflon, Teflon ribbon. Actually, this is Teflon tubing, okay? It's heavier. It doesn't tie as well, but it was the only thing we had available, okay? Until I worked with a company, we made Spectra. This is fishing. It's been used in heavy ropes for marine applications or braided fishing line, the Spectra. It essentially floats or almost floats. It's the gravity is 0.98. Anyway, it weighs only 28% that of the Teflon to the right-hand side here, but it's more than 77 times more abrasion resistant. We did a formal test, abrasion test, with like to do with other fabrics, and we found that it's a test where you put a piece of over a metal pipe, and it goes up and down with a 4-pound weight on it, okay? And the Teflon broke at 650 cycles. We stopped the test at 50,000 cycles with the Spectra. And so the owls are not getting this one off. And it's way lighter, way easier to work with. It's a much superior harness for, now it's been made into applications for all kinds of ornithological work. And it's a lot, surgeons use this. It's been FDA approved for internal use in humans for suturing, for stitching up in internal medicine applications. Huh? So it's good stuff. Okay, well, now look at this. These are all, if you can see these lines, these are all transmitter lines of different female burrowing owls. Here's some of the ones that we had from the depot and nearby. They went down to California, like we had seen with the geolocators. From the ones from Idaho, they also went back down to Baja and so forth. Those from Saskatchewan and Alberta and other places, South Dakota, Nebraska, Colorado, so forth. Essentially, they all went down to Mexico. They don't fly together. The only pattern is that they fly around the east flank of the Rockies. It's a risky operation to try to fly across the Rockies. They will fly across the Sierra Nevadas, no problem at all, up and over, no problem. So, but this is a 5-day flight. They basically get down to Lubbock, Texas, and there's a holding spot there for them for about a week while they refuel, and then they go on to Mexico and all over the place there. So we've really learned a lot about them. Here's California, okay? Here's Santa Barbara. One of our owls from Washington flew down, got to the coast, waited until about midnight or 1 o'clock in the morning, and then flew across 30 miles of open ocean to Santa Rosa Island. And she spent the winter here. And I lost signals for 2 or 3 months. I was really worried about her. And I had sent a team out there that were doing bald eagle surveys. I said, can you go to this point? I think she's out there, but I can't get any signals. They said, oh yeah, we were just out there. There's a peregrine falcon nest about 150 meters away. So it's no wonder she didn't come out of the burrow. She's feeding at night and so forth, and just spent the whole winter there. And then when she got ready to migrate back north, went over to Santa Cruz Island and then back, and then zipped all the way right up to Washington. Just nothing to it. What we found with that satellite transmitter work, this is in Salina Valley, California, okay? The owl wintered in this burrow for 2 years until it collapsed, and then wintered in this burrow for the next 2 years. One female came back to the exact same spot. And that's routine with these owls that go to Mexico and other parts of California. They will go to the same exact burrow. The site fidelity is higher to the wintering sites than it is to the nesting sites. It's because if you were a bird and you wanted to have a good, happy winter, if you found a place, why not go back? So these places are fundamentally important to wintering birds, okay? So I've been working with folks in California about protecting the wintering burrows of Oregon, Washington, and Canadian birds, knowing full well that these are almost as important, or probably more important, than the nesting burrows. It's so fundamental, huh? So, but this is not nesting habitat. This is way steeper than a nesting habitat would be, and much more vegetated. Okay, but it's a good wintering site. Okay, mate selection. This is a female burrowing owl on top. This is a male here down below. As this, they all molt in September and October, complete molt, okay? And then the new feathers are all dark brown. But by spring, the male spends more time outside, and during the nesting season, he bleaches out, his feathers bleach out with the UV light on the from the sun. And so, but he also has a bigger white bib, a little bit wider eyebrow, white eyebrows. And so, and he's also a little bit smaller than the female. There is reverse sexual dimorphism. Females are heavier than the males, all right? Okay, well, that's interesting. So we traced the wings and got other body measurements of about 75 mated pairs, both males and females, of 75 mated pairs. And we said, what do we learn about the wings? That's what we started to be interested in, but we found out when you take the wing tracings, and this is a little square here, this is called it's a software program that analyzes the area of the wings. Okay, it's actually designed for leads on plants, but it works great for wings. It just turns them green, that's all. And that's okay. Merry Christmas. So, but we did all that with all these wings, and we found out that there is a positive linear relationship between the wings and weights of the mated pairs, and with the males and females. That is, large females pick large males for their mates, small females pick small males for their mates, and everybody else is on this linear relationship between small to large. We thought that seems unusual, is it? And because we're so used to deer and elk and other species that everybody wants the females want to mate with the big guy. That's not the case with burrowing owls, and it's not the case with other owl species either, as we're finding out. So if it's a good food year, everybody does fine, okay? If it's not a good food year, then the ones that are the smaller are more successful because they need less energy to succeed. So, it maintains variability in the population, and especially in northern regions like Oregon and so forth, where there's an unpredictable food source, Finland and other places with other owl species. So it's driven by energetics, but it maintains that somebody's going to be successful in that population, and not everybody's going to crash and burn if there's a bad year. So there's a real evolutionary pressure for owls to be small. We didn't think of that. It's advantageous when you're big if it's a good food year, but only if it's a good food year. Oh, okay. So that's something that we didn't know or expect until the studies we did there on the depot and elsewhere. Nest decoration. Burrowing owls, males, decorate like crazy, some of them. Their entrances to the nest burrows. And they'll bring in coyote scats, the moss, chunks of grass, and a lot of it, cattle dung, bison dung, antelope dung, whatever, coyote, and so forth, pieces of plastic, pieces of concrete, old gloves, and all kinds of stuff, sticks. Here's one. This male brought in, I counted them, 105 pieces of grass wads. Just the root wads. I don't know where he got them, but he's certainly spent a lot of time and energy doing it. Now there's some coyote scats involved in here too, okay? So why the heck all of this decoration? And so there's been various theories about why they did that. Okay, well, this one's in Florida. He found a paper supply source second to none. Yeah? And so he brings all this stuff in, and so it's white. It happens to be white. That's of relevance too here. So, but they bring in a lot of decoration. Well, a lot of species don't decorate. Some species like bowerbirds decorate to attract a female, okay, attract a mate. These guys, the males don't start decorating until they've already mated and the female has started to lay eggs. So it doesn't start until she's with eggs, has eggs down. So we did a test. We said, does color matter? It seems like there's a lot of red and white at some of these sites. So we put down these 9 color swatches of fabric. They're all velvet, huh? And so the owls preferentially chose, this is in captivity, but they do this in the wild too. They preferentially chose red, white, blue, and green in that order. And they never touched the other ones. Never folded a fabric on the other ones. I never touched them over the course of months. So we did a test. We put out red fabric, white fabric, numbered pieces, corn cobs dipped in white or black paint, and then coyote scats tip was dipped in white or black paint. At 20 nest sites, at 20 other nest sites, we put it 15 feet away, 25 feet away, and then at 18 nest sites where we didn't do anything. So here we go. We put out 4 coyote scats, 4 corn cobs, 2 red fabric, 2 white fabric at the nest sites proper, right in front of the aprons, all right? And the idea was to say, what do they do with those, all right? Do they bring in more stuff? What do they do with this stuff? And, all right, and then here's a supply station. This is 25 feet away from a different nest site. We didn't do anything at the burrow entrance, just at the supply station. Same kind of stuff, but numbered red and white fabric, white tipped corn cobs and coyote scats, okay? And some of this, we went back every 10 days to check and see. If stuff was missing, we refilled it, okay? We resupplied it. We did that at the supply stations too. And then at the end of 60 days, the end of the nesting season, we went back, pulled all the stuff out of whatever was on the apron area in the vicinity and whatever was in the burrow, put it all back together, okay? You'll see here, this is the black tipped corn cobs, right? And whatever coyote scats were there, all right, at this burrow. And we weighed it all and we did all that kind of happy sciencey stuff, right? Counted it and weighed it all. So what did we find? We found that the females will bring whatever they want to bring in. They'll bring in and shred to line the nest to make it nice and soft. And the stuff that's a reject, that a corn cob doesn't shred very easily, they'll put that off to the side in the nest site in a little reject pile. And so they only use the best stuff to make it really nice and soft and to line the nest. The males, this is all for them. It's not only about supplying the female. This is a defense. No, excuse me. A strength thing. So I put some of this material out at nest sites at lunch at noon one day, and went in, came back, had lunch, came back out at 1 o'clock, and this guy was calling, territorial calling. He knew that somebody else had put decoration in front of his burrow and he wasn't having it. And so he recognized this stuff as decoration. And so he was active aggressively. And so it was kind of amazing that, and I've had photographers go out to these places and they'll move some of the stuff that was right in front of the burrow to get a better picture. The male comes back in, looks at him, glares at him, jumps down and moves it back. And so they're very specific about what they bring in, where they put it, okay, and why they put it there. So, okay, in the collective sense, then, with all of our data, we found there's 2 reasons that the males are doing this. One is to supply the female with materials that she can shred to line the nest cup. But the other one is, one of the primary ones, is to advertise dominance to other males. And I think it's also advertising to future females. I'm a tough guy. Look at this stuff. There are males, younger males, that didn't bring in anything. And in fact, we had a number of males that went over to their neighbor's place and stole all their stuff. And it was up to 1.5 miles away that they would carry the corn cobs or the fabric, especially the red fabric. They like the red fabric. And so we had the fabric numbered so we can tell actually where it came from and who took it to where. And so there's other hypotheses that they decorate to attract insects for the youngsters when they come out. Well, it's a dry environment, and it just didn't make any sense that they would bring in stuff that would never be used by insects. Okay, owls can't smell, so it doesn't make any sense for it to be a scent thing. If you're trying to cover up the scent of coyotes, why would you bring in coyote scat? Okay, or corn cobs. So anyway, that didn't, well, and they don't use it for courtship because they're already courted and they're already mated, and the female's already, so it's like, I think these are the real two reasons. Again, remember when I mentioned that the males don't want to fight because the risk of injury is so high? This is one of the things that you can do. You can decorate. If you want to be a tough guy, decorate, okay? There were chunks of concrete, and nothing says tough guy like concrete. Okay, let's go on to artificial burrows. We've learned a lot about artificial burrows in the course of time. This is the design I've put in as a rescue mission in many places for burrowing owls. I would much rather see the fossorial animals that make the burrows be promoted. In some places, it's just not going to happen. So we've been putting in these paired sets of burrows. They're independent burrows. The tunnel length is 3 meters, 10 feet, because that's the average length of 400 natural burrows that I measured in the western US. So they're 10 feet long. These are 55-gallon barrels cut in half. We put rock out here. They're about 15 feet apart, 5 meters, the entrances, so that if a predator comes, they have to choose whether they're going to go to this one or this one. They can't do both at the last second. So, and there's a T-perch out here because it helps us to find it. The owls have evolved without T-perches. They don't need them, but it certainly helps us. Okay, underneath is a wire mesh to keep the paca gophers from coming up from below. And once they find in there, they said, this was one of David's burrows. We got to plug this up. So the wire mesh is there to protect against that, and badgers. Okay, there are 2 pails here. The top one is intact. The bottom one is cut out. There's liquid nails as a sealer between this. Okay, we lift the tunnel. This is 6-inch tunnel. We lift it off the bottom about 3 inches, so that so the females and so forth, you can have 4 inches of sand inside the chamber, and the female can still dig down a nest cup without hitting the wire mesh. If she hits the wire mesh, she will abandon. I'm not laying my eggs on that. Okay. We dig a hole, the wire mesh goes in, the chamber goes in. That has a slight bend in it, slight arc in it, to me more like a natural burrow, but also to keep the sunlight from shining in directly to the chamber. Okay. You can see the wire mesh underneath here now. We'll put in 4 inches of sand on top of this. All right, so this pail has got the bottom cut out of it. All right. The top pail is half full of sand as an insulator, but we also want to be able to lift it off anytime in the future. Everything's buried. The only thing you see is the tunnel entrance. And we armor that against coyotes and dogs in many places. And then in places where it's wetter, like it is in Oregon, I put weed fabric down with pea gravel on top so that I don't have to fight the weeds that grow up around here. The owls fertilize this area, okay? So the weeds that grow up around here are twice as tall as they are 30 feet away. It's a good way to find nests from last year, is all the fertilization in the weeds. So anyway, this is what a finished set looks like. We've had owls take occupancy within 24 hours of these burrows. They find them. Their life depends on burrows. They know how to find them, okay? And with this kind of operation, they look for this dirt splay like a badger would make, or a prairie dog would make, some sort of a disturbance into the dirt, into the sod. So they find these things fast. Yeah. And then they take up residence. Okay, they have 8 or 9 eggs like this one. Here's a little bit of a prey item from last night, deer mouse. The babies hatch, you know, of course we can lift the pail off and check on them. All right, we record the hatch date of the oldest one, so we're able to monitor climate change. Are they hatching different later in the season or earlier in the season, or how can we tell? So we recorded this. I've recorded this now at about 550 nesting sites of burrowing owls in the last 12 years. Yeah. And then we come back 20 days later to band the kids, and they welcome us with open arms, open wings. Now they're not happy. And then they give a sound that sounds like a rattlesnake, and it really does sound like a rattlesnake. We've done some analysis of the vocalizations, and it really does overlap with the sound of a rattlesnake. So it's an impressive defense. Still makes me nervous after all these years. Thousands of burrows I've opened. They don't all the artificial burrows don't have to be underground. You can put them above ground if the situation requires. This is a site in Aruba, but it could be anywhere there's hard packed soil or wet soil underneath. And so it takes 5 cubic yards of material to cover these 2 side-by-side chambers. Yeah, it works great. And owls moved right into them. One of the things I did was I tested whether a 4-inch diameter tunnel here or a 6-inch diameter tunnel. Okay, so I put one of the burrows, you've seen the paired burrows, one of them got a 4-inch and the other one got a 6-inch. We randomly selected which got which. When the owls nested under the 4-inch tunnels, they dug a big hole underneath. Then they never did on the 6-inch. And they did this a lot, almost every time. And I was trying to figure out why the heck they're making this big hole. And it turns out they dig their own entrances when they can. They dig them bigger. Okay. Well, why do they do that? They do that because of predation. It's a real deal. And this is a harrier, an immature female harrier that must have had some success, because I would see her making a route around the depot from one burrow to the next burrow to the next burrow to the next one every day. And so the youngsters would never get caught here because they had enough area where they could run back in. But if you have a 4-inch tunnel, guess what I found? The owls will nest in them, but the reproduction is at least 30% or more reduced because of the 4-inch tunnel. When all the kids are outside and they make a dash to get inside, little Joey on the end always takes it. So reproduction, if you want to put in a 4-inch tunnel, you can, but you're just going to feed the harriers or coyotes or other predators. And that's not the intention. So we've learned a lot about diameter of holes now and what it means to the owls, just purely from a predation perspective. So, okay, the recommendation is you either use a 6-inch tunnel for the whole 10 feet, okay, or add an escape patio on the last 3 feet so the youngsters can run in there 2 abreast, get out of harm's way, and then make their way into the nest chamber. Okay, photography and blinds. I've been working a lot with National Geographic and other professional photographers and lots of amateur photographers too. Everybody wants pictures of burrowing owls, and you always want to get closer and closer and closer. And so it turns out that burrowing owls, for the vast majority of their range, are very skittish. The owls in the depot, when I get within 100 meters, they flush. And so either they know me, and that might be, but they generally flush. They're much more shy. Okay, if you want to get photography, you can't walk up to them. You have to have a blind. Well, no sense in having a soft blind that's going to flap around in the breeze. You got to have a hard blind. So we put a plywood blind out here. We put a lot of rocks on top to hold it down in the wind. Okay, there's a portal on the right-hand side here. We just put these up for the night. These are infrared light posts. These are infrared lights for nighttime work with National Geographic. The nest site of interest is back here. Okay. What I've learned is that the blind itself cannot be closer than 50 feet. I've measured it off. If it's 44 feet, it's too close. The owls will not habituate to it. 50 feet or more, yes, they will habituate to it like this. They'll come and sit on it. It's the tallest thing in the landscape, right? And so here's the deal. A minimum of 50 feet. If it's 60 feet, that's even better. Okay, the owls will habituate to it probably the same day. 75 feet is no problem. So long as the blind is the viewing port, the hole in it, is the same level as the burrow entrance. If it's like this, everything works out cool. If the blind is a lot higher, then the owls see that as a threat. They can't see what's behind it, and they worry about it all the time, and they never can let the guard down. If there's a harrier or a red-tailed hawk or a coyote behind that blind, your life is in danger. That's what it means to them. This is not about can we get a little closer. This is about a real life threat to the owls. Okay, so minimum of 50 feet between the blind entrance and the burrow. 4 days for the owls to actually fully acclimate to the presence of the blind. Viewing port needs to be the same height as the entrance. We put mesh, that same kind of mesh I use in the bow nets. Okay, so a mesh, hexagon mesh over the hole, and then make a cut in it so that you can get the camera lens out. You know? Okay, we've also found that the owls always watch the people inside. In fact, they watch your eyes. If you put sunglasses on, they lose interest, just like that. We were surprised. But they can't see your eyes, and eye contact is fundamental to these. This is what danger is really about for them. So this is my message for based on 10 years of working with blinds and photographers. So please, you know. Okay. Next steps. We've got a project now. We're reviewing the taxonomy of all 22 subspecies of burrowing owls in the Americas. 2 of these subspecies are already extinct. They're from the Caribbean, different islands in the Caribbean. The other 20 are still alive in some measures, more or less, in terms of numbers, okay? How do you review the taxonomy of any species? Well, there's 4 things that really drive a systematic review, okay? Genetics, all right, getting blood samples. In our case, we want blood samples. It's about 3 or 4 drops of blood from 5 males and 5 females per the subspecies. We get ancient DNA from those 2 extinct taxa I mentioned, from the toe pads. You get a little chunk of the tissue of their foot, and then hope that you can ahead of time find a lab that has got a good record of extracting ancient DNA, or you shouldn't do it. And so these are extinct species. All right, so we want to make sure that we can actually get the DNA that we're after. So in our case, we're sequencing the complete mitochondrial genome and several nuclear genes. With this information, we should be able to track the origin of burrowing owls in the Americas and their radiations across the Americas. You know, it's a strong, very strong data set. Okay, morphology, we're measuring 16 detailed body measurements from 15 males, 15 females as a minimum. Normally I see if I can't get 50 of each, 40 of each. Vocalizations, we're recording the territorial calls from 10 males from each subspecies. Be surprised how different they are. You know, the birds from Aruba are much more musical than the owls from the males from Oregon. And of course the Arubans say, of course they are. So distribution maps, of course, it's always a chasing game with maps and observations and habitat, but certainly that's the intent here. So we get a blood sample. This isn't from an owl, this is from a shorebird, but it's the same process. A little puncture in the vein here by the wing, a hematocrit tube. You draw the blood and you immediately move it over to these Wattman cards and you put it on as a sample. This fixes the DNA so it no longer degrades. You let it air dry and then you can ship it to the lab. In our case, it's San Diego Zoo. One of the things we're measuring is the wings, aspects of wings, because they're so different, if you will, on the evolution of owls. So this is primary number 10. This is the outermost one. Primary number 9, 8, 7. They count inwards down to number 1. All right. Here's a real burrowing owl. The other one was a screech owl, but you get, it's the same process. Yeah. So 10, 9, 8. The longest one here is 8. Yeah. 7, 6, 5, 4, 3, 2, 1. So in Oregon, the longest primary is number 8. In Aruba, the longest primary number is number 7, P7. Their wings are different. Oregon birds are migratory. It's beneficial to have a long pointed wing like an albatross or a peregrine falcon or a swallow if you're a long distance migrant. If you're not migrating, you don't need that, okay? You're better off to have a short rounded wing so it gives you better hunting. And so we're seeing the evolution of owls right here in their wings. We also see it in the how much feathering is on their tarsus. Okay, look at this. This guy's leg is feathered right down to here. Now it has bristles, all right, but feathers are here. And this one from Venezuela, it stops here. Okay, so we're, as a pattern for the different subspecies, this is another thing that jumps out as being different. So the question is, when you do all this genetic and morphological and vocalization data, how much is enough to make the species different? Okay, so yes, we expect to be a little bit of difference, but if there's really significant differences in all these facets, the genetics are different, the vocalization is different, the feathering is different, the distribution, okay, then it starts to qualify for full species status rather than subspecies. This is a vocalization. You heard it earlier with the cuckoo, cuckoo, cuckoo. This is an Oregon burrowing owl. Okay, but we look at this is the left and right speaker from one of my high quality recordings. Yeah, but this is the kind of information. Well, we look at how much time between the start of this one and the start of this one. What about the nuances, the frequencies, the pitches, the harmonics? There's 5 different kinds of software that we analyze the vocalizations with. Yeah. For the subspecies that we can't access or there isn't enough to access, okay, then we rely on museum specimens to get the best information that we can. I don't anticipate that I'll be going to Cuba anytime soon. All right, but we certainly can. I have colleagues in Venezuela and Brazil and Argentina and so forth, so I'm trying to find someone in Cuba. But as a backdrop, a backup measure, there are specimens in the various Smithsonian in New York and Chicago and other museums that I can access. Yeah. So we try to take full advantage of all this. We'll probably end up with something like 2,000 owls that we'll have measured, you know, or more. I mentioned the distribution maps as a chasing game. We're updating the burrowing owl distribution for the USA and Canada. It's substantially reduced compared to this now, and it's contracting and becoming more Swiss cheesy as well. But in trying to sort out these subspecies and whether how legitimate they are, or if they are in fact new species, now this takes an effort in distribution mapping. Yeah, but that's let's do it. This is my last slide. I haven't talked about owls in myth and culture, and I bet you're feeling somewhat like this young girl here about now. But the idea is that myth and culture and how the human-owl relationship makes a great deal of difference in how owls are protected and conserved. Aruba, the shoko, this is the shoko, it's a burrowing owl subspecies. The local name for it is a shoko, and it is the national symbol of Aruba. And so they take great pride in protecting and conserving their owls on the street level. So I'm going to stop there, and this is where I let Joe and Carla kick in with any questions that you all might have. Thank you for your time. This is a big, important piece. I appreciate it.
Okay, awesome. This is fantastic. I was taking lots of notes. This is fantastic. I appreciate this so much. Hey, Joe, do you want to start out with the chat questions? I think there were quite a few.
We had 4. Two of them were about the video you showed. Was that the same owl going back and forth investigating that trap?
Yes, it was the territorial male. And so, yes, it was only one bird. It was a male.
Sorry.
The females don't engage in that kind of trap. They don't respond like that because it's not their job. It's his job. And they'll stand there and watch him. And it's like, come on, Bob, get with it. Take that guy out of here. Yeah.
Someone asks, have you caught that male again the next year?
Yes, I have. Yes, in fact, there are some males that I've caught. I banded them as kids, and I caught them as 2, 3, 4, 5, 6, 7, and 8-year-olds. So I've caught them every year. And so part of the question often folks ask is, do they get trap shy? And I say, no, they don't. If you only catch them, and I only handle them one time per year, typically, they are so motivated and so driven by that other male, that pesky intruder male, that that overcomes anything else that I might have done. And so, but when I do set the trap, I drive away. I am not in view. If I was in view, the owls would sit there and look at the trap and then look at me and then look at the trap and then look at me. So I'm a distraction. So I leave the scene. So it leaves them to their regular duties. I catch them faster as they get older. Yeah.
Do you find other animals taking up residence in the artificial tunnels?
I don't. Well, I'll take that back. We've had cottontail rabbits take up some, and we actually have had a lot of deer mice nest inside the chambers. I think that's like a B&B for the owls. Yeah, that's a risky maneuver for the deer mice, but it does tell me that deer mice need tunnels, okay, and that they like the chambers, and that they will reproduce in them. Otherwise, I was kind of anticipating snakes, and I've checked 8,000 burrows, and 8,000 times I've checked burrows, and the only snakes I ever find in there are prey items that the owls have taken themselves. Snakes don't go in there, and there are snakes all around, gopher snakes and racers and so forth, and sometimes rattlesnakes, but they don't go in there. We've had one occasion in Arizona. It gets so hot, they got to be someplace. So. Yeah, but otherwise, no, the chambers stay pretty empty. Ground squirrels will go in them where there are ground squirrels, and sometimes they'll take over and they'll stuff the entrance with rocks to make the hole from this big to this big, because it's safer for them. So, yeah.
And then the last question is a complicated one. How does climate change affect the burrowing owls?
Righto. So the evidence so far is that in the southwest, southern U.S. and Mexico, it gets hotter, drier, okay? And that negatively impacts the food base, all right? And we've seen major declines in burrowing owl numbers because of the habitat stays the same, essentially structurally stays the same, but the dryness has driven small mammals kind of off the edge, and grasshoppers and other insects really suppress their numbers. So we've had places that had 72 or 75 pairs of nesting owls down to 3 or down to 2. It's really just slammed them, okay? In the Northwest, Oregon, Washington, British Columbia, Montana, Idaho to some degree, in the inland states, Minnesota, Dakotas, it's wetter and colder in the spring. And so we find on the depot and other places there, especially in British Columbia, it's so wet that either the burrows will flood, okay, or it'll be cold and wet for a period of 4 or 5 days, right about the time when the youngsters are hatching. So here's a female that's been food stressed, the male has been doing his best, and now he's under pressure to deliver even more food. It's cold and wet. He can't really hunt very well in the wet, the dripping, raining wet. The kids hypothermiate and die. After 4 or 5 days, the weather clears, he's able to hunt again. That all of a sudden the brood is half of what it used to be, okay? And so it'll dramatically and the rest of the season will be fine. And you kind of go like, I wonder what happened. And it turns out that there was a window of 4 or 5 days and it just body slammed the whole population that had kids then. Huh? And so it's a major driver. And so right now the idea is, are we just seeing wild variations, you know, in the number? So on the depot, I will see sometimes 65 pairs nesting. A couple of years later, 39 pairs nesting, okay, then 50. And so I thought there'd be some sort of, you know, relatively leveling off, but it is just a wild ride in all these nesting years. And so that's the kind of stuff you see with climate change. It's really real for the burrowing owls.
There have been a few more new questions. Does the male ever go in the nest chamber?
He does. He certainly does at the beginning of the season. But many of the males, once the female starts incubating eggs, that's her domain, and he just stays out of there. It's just trouble for him. So rather what he'll do is he'll bring in food to the doorstep, and he'll drop it off right in front of the tunnel entrance, and he'll say, pizza delivery, and then off he goes again, okay? If he has excess food, he'll put it in the second burrow, the cache burrow, and he'll stash food in there. When he first gets there, he'll start setting up shop on 2 or 3 burrows, and you'll have a little food in each one, just in case she picks that one, okay? He doesn't really know. I don't think he really cares. That's up to her to pick which one she wants to nest in. And it might be this one this year and that one next year. You know, it depends on. And if she's successful in producing 2 or more kids, that's success. And she'll likely come back next year to nest again to that same site, the same guy. There's no reason for the guys to switch around nest sites because he memorizes that territory. He literally memorizes it, so he's a really good hunter in it. Even if it's not a great territory, it's the one that he has, okay? If she's not successful, doesn't produce any young, then why would you want to go back, okay? So she will, the site fidelity is a little bit based on whether she was successful or not, okay? So, okay.
And I think we're running pretty low on time because we do have another program starting at 5. I wonder if you can touch on one more thing. Can you talk about burrowing owls as cornerstone species?
Yes, absolutely. So, like I mentioned at the outset, these are grassland shrub steppe birds, and they're one of the predominant predators in that environment. And so their role there is as an insect control, small mammal control, barometers of health of that system, as well as it relates to the fossorial animals that make the burrows for them, okay? Here's a little bit of an insight on the National Guard property, the Army base there. There are troop maneuvers, troop training, okay, bivouacking sites and so forth out there. And they had done a study saying, oh no, there's hantavirus out there. We need to catch deer mice to see if in fact they have hantavirus. And they have in the past. They're kind of, it's everywhere, huh? So they went out and they said, we need to catch 50 deer mice. And they showed me the sites where they wanted to catch them. And I was going like, oh no, if they go out and they catch them and they find deer mice and they find that they have hantavirus, they're probably going to want to poison them. And I thought, that's not what the owls really need about now. And then I thought, you know what? I bet the owls have caught most of those mice. So go ahead and go for it. So they went out and trapped for deer mice in those areas in the field where the owls were. They didn't catch any deer mice. It was only around the administration area and a couple of other places that did not have any owls around them that they caught their 50 deer mice. And so the way I perceived it, but the way other folks have perceived it as well, is that deer mice are out there, but they're under control because of the burrowing owls. And so it's a human benefit in the case of our troop training and those kinds of places. And so that's just a tip of the kind of iceberg that burrowing owls offer to the landscape in terms of health and ecosystem functions. Yeah. Okay.
Okay, thank you very much. David, are you okay sharing your email address if people have further questions, or would you prefer they funnel questions through us, or?
No, it's fine. You can contact me directly. The best email address, the easiest one, is simply D as in David, and J as in Johnson, OWL, owl, at AOL.com. So DJOwl at AOL.com. I know there's probably a number of you that would like to help in some fashion. And what can you do given where you are and given COVID and so forth? So there's a lot of people. I have about 450 people that work with me in 66 countries on the science and conservation of owls. So it's not just burrowing owls. So I think we can probably find a project for you that might tickle your fancy that you can really help contribute towards. So, but feel free, contact me directly and let's work something out. Tell me where you're from and the kinds of things that tickle your fancy and you might be interested in doing.
Okay, whoops. Thank you very much for participating. And I know David always likes to answer questions, but I know he's shy about asking. I think